Let's look at section 3.1 and let's talk about quadratic functions. In previous sections, we've seen quadratic parent functions. We saw how to take a graph of f of x equals to x squared and to modify that to create the graph of some other quadratic function. So for example, we could do something like, we're going to go ahead and graph f of x equals 2 times x plus 3 quantity squared minus 1. We could take a parent function and modify it according to the operations in the function. Note that this is basically just x squared. If you ignore all the minus, the pluses, the times, and so forth, this is basically just x to the second power. So if you ignore everything besides the parent function, well then we know exactly what the graph looks like. The graph of y equals x squared, the graph of f of x equals to x squared, is simply a parabola crossing through the origin, and that's facing up. So our parent function would look like this. So something like that. Okay, now we have a few changes that we can make. Note that this plus 3 is in the parentheses, so it's going to go first. So this is our parent function. Adding 3 to the argument of a function is going to move it to the left that many steps. So this is going to be our first operation. We're going to move everything to the left by 3 steps. So this is going to go 1, 2, 3. So now instead of having this at 0, 0, now it's at negative 3, 0. I still have the same parabola, the same size and shape. It's just slid over a bit. Something like that. I have multiplication and I have subtraction left. The order of operations tells me multiplication should come next. And in fact, here, because this is being multiplied by a number that's bigger than 1, it's going to make everything taller. So it's going to be twice as tall. And so now it's still going to be the same shape. So I'm going to start from this point, but now instead of going out and up this way, it's going to go out and up twice as high. And same thing over here. It's going to go out and up twice as high. So it's still in the same spot, but now everything's taller. Okay. And now that minus 1 is the last thing left, and that's telling us to move everything down 1 step. So now from here, we're going to go down a step, and now instead of being at negative 3, 0, now we're at negative 3, negative 1. And we're still going to have this kind of a graph. It's still going to be a tall parabola. Something like that. Yeah? And in spite of the messiness of my drawing, that is a decent graph. Well, yeah, I suppose. But notice how much detail we're missing. Yeah, okay, we moved this point over. I know for a fact this point right here is at negative 3, negative 1. Where are all my other points? Where does it cross the x-axis? That looks like negative 2, 0, maybe. Or maybe it's negative 1 3/4, comma 0, or negative 2.01, comma 0. Again, I'm not sure. It's around there, but I don't know exactly where. Likewise, I know this is supposed to keep going, but I mean, eventually it'll cross the y-axis. Where does it do that? What about all these other points? There's a bunch of other points on this curve. What are they? Do I even need those? What do I need? So in the previous chapter, we saw how to use a parent function in this case y equals x squared, the basic parabola, to give the graph of a function in the same category using these transformations. Translations, dilations, and not pictured here, reflections. But now let's talk about more of the details, because this isn't really a full graph. It's more of a sketch of a graph. It doesn't give you all the full details. Okay, well, what are the full details and how do we find them? So in this chapter, we're going to be looking at modifying and adding more details to these kinds of graphs that we have. These parent functions and these transformations of parent functions aren't going to become obsolete. We're not just going to throw them away. They're going to be the starting point. They're going to be a basis for what we're doing. But once we have these graphs, then we're going to use these and add details to them, add information to them to help us get a more thorough graph and a more thorough idea as to what the function is and what it looks like. Okay, so let's take a look specifically with a quadratic function. We'll look at other parent functions and their details in later sections. So let's start this off with a definition. Let A, B, and C be real numbers. Technically, you can deal with complex numbers here. And in fact, in a few special cases throughout this chapter, we will be using complex numbers a time or two. But for the most part, and definitely for now, we're going to start off with real numbers. So let A, B, and C be real numbers, where A should not equal to 0. The other ones can equal 0 if you like, or they don't have to. But here specifically, we want A not to be 0. Then an equation of a function given by f of x equals ax squared plus bx plus c is a quadratic function in standard form. Okay? If you take this quadratic function and rewrite it in the form f of x equals ax minus h quantity squared plus k, you might say, how am I going to change that into that? We'll give the details here momentarily, but essentially it's going to be completing the square as we've seen in chapters 1 and 2. If you write your function this way, this is the vertex form of the quadratic function. Where the vertex of the parabola is going to be h comma k. So here, let's go ahead and write this out with some details down here as bullet points. So the vertex is the point h comma k. The value a, whatever number this is, if it's positive or if it's negative, tells you the direction in which your parabola is going to open. Here, if a is greater than 0, the parabola will open up the way this one did. And the vertex is a minimum. On the other hand, if a is less than 0, then everything is upside down. The parabola opens down, opens. So instead of opening up that way, it would come down this way. It would be upside down, opens down, and the vertex is a maximum. The axis of symmetry is given by the line x equals to h of the parabola. Okay. So here we've defined quite a few things here. Quadratic function in standard form. That's this type of function. F of x equals number x squared plus number x plus number. If you write it in this form, number times x minus number quantity squared plus number, that's called the vertex form of a quadratic function. Okay? The vertex of a parabola is a point. And in fact, it's the point h comma k, where h and k are the numbers here. If a is greater than 0, this number here, which incidentally is the same as this number here, right? These are the same a, then the parabola opens up and the vertex is a minimum. Here we're not defining anything, this is just a matter of fact. And if a is less than 0, then the parabola opens down and the vertex is a maximum. Here, the line x equals to h is the axis of symmetry of the parabola. Here we're defining the phrase axis of symmetry. Okay, that is our definition, or rather these are our definitions, there are several, and a quick illustration I think may help cement some of these. In every case, whether we write it in the standard form or in the vertex form, when you graph a parabola, it's going to look one of two ways. It's either going to be opening upwards this way, or it's going to be opening downward in the other direction. Something like that. Okay. This point where the parabola sort of turns around, that is our vertex. The vertex, if the parabola is opening up, will be the lowest point of the vertex. So here, if a is greater than 0, if the parabola opens up, that's a minimum. You find the vertex at the point h comma k. On the other hand, if the parabola is opening downward, because a is less than 0, then your vertex will not be a minimum, it'll be a maximum. It'll be the highest point of the entire graph. This keeps on going down forever, just like this one goes up forever. So the vertex is still going to be found at h comma k, but it'll play a different role. It will no longer be a minimum, now it's a maximum. The axis of symmetry of a parabola is going to be found as a vertical line that passes through the vertex. This is called the axis of symmetry because everything to the left of this line will be identical to everything to the right of this line. Or in other words, this line will act as a mirror. This will be mirrored over this way, or if it's on this side, this will be mirrored over this way. Okay, so let's define some of our terms, define some of the words that we're going to be using, but it still doesn't really tell us what we're looking for. After all, we said we're going to be graphing some details on top of these kinds of parent functions, on top of these transformations of parent functions. But what details are those? If I'm asked to create a full graph, not just a sketch, what am I doing? What am I looking for? So let's do this through an example. In fact, we're going to use two examples. The first one is going to be given in the vertex form. When things are in the vertex form, things are a little simpler because there's less algebra for us to do. There's a lot less to do and a lot more of just picking out information. The second example, it will not be in the vertex form, and we'll see how to handle that. All right. So here we're going to say graph the function f of x is equal to, let's go with 2 times x minus 1 quantity squared plus 3. And here I'm going to put a minus in front of that. Okay. Here, what do I need? Well, first of all, I'm going to need a graph, right? I'm going to need a shape of a graph. This is a parabola. And I know that because of chapter 2.6. I can tell that that's going to be a quadratic. It's x squared in its most basic form. So, since I know what the parent function is going to look like, I know the basic shape of the graph. But here we're saying that's not enough. We're going to need some details. Okay, so what are those details? Well, we're going to want to find the vertex. The vertex is going to be the point that is either the maximum of the graph if it's pointed down or the minimum if it's pointed up. We're also going to find the y-intercept. You'll remember that back from the beginning of chapter 2. The y-intercept is where the graph crosses the y-axis, which is found by setting x equals to 0. And we're going to want to find the x-intercept, which again you'll remember from the beginning of chapter 2 is the place where the graph crosses the x-axis. You can find that by setting y equal to 0. Note that your function will often have multiple x-intercepts. In fact, 2 of them. A parabola will often cross the x-axis twice. Also note that it's possible it will never cross it at all. Right? If it's entirely above the x-axis, then it means it never crosses the x-axis. So note that oftentimes you'll have 2 x-intercepts, but you might also possibly not have any. It's also possible to have just one. If, for example, your graph touches at just that point. It came down, hit that point, and then came back up. So it is possible to have just one x-intercept. So here I'll go ahead and put this in parentheses. I'll put a little s there because it's x-intercept, or although possibly x-intercepts. You may have more than one. In fact, often you will. All right, so vertex, y-intercept, and x-intercepts. Fortunately, all of these are relatively simple to find in this form because this is the vertex form. And the vertex form tells us the vertex, hence the title. Yeah? If you have something in the vertex form, this h is the x-coordinate of your vertex, and this k is the y-coordinate of your vertex. That's exactly what we have here. Here's your h, it's the number 1. Here's your k, it's the number 3. And that's it. There's nothing else to do. You pick it out just by recognizing what components you pick out from your equation. So here that's going to be 1, 3. Whatever number is being subtracted from x, that's your x-coordinate. Whatever constant is out here by itself, that's your y-coordinate. You might also think of it as whatever number you plug in here to make this 0, that's your x-coordinate. Whatever number this is, that's your y-coordinate. There's a few ways you can think about it. Either way, 1, 3. Okay. The y-intercept. The y-intercept we simply find by substituting in x is equal to 0. So set x equal to 0. Here, this is going to take just a very minor amount of work, although you'll note that for quadratics as well as cubics and linear equations and really just about every graph we ever have, y-intercepts are never really going to be very complicated because all you're ever going to do is plug in x equals to 0 and then simplify. And in fact, we're going to do that now. Here's our function. Now remember, f of x is another way of saying y. So here, I'm going to even write it as y. I'm going to write it as y equals negative 2 times x minus 1 squared plus 3. Now, once again, I'm trying to find the y-intercept, and that means I need to set x equal to 0. So right here, this x, I'm going to set that to equal to 0. Okay, so now let's just simplify. Order of operations, parentheses go first. 0 minus 1 is negative 1. After parentheses come exponents. Negative 1 times negative 1, right, squared. That's a positive 1. So that's negative 2 times positive 1 plus 3. Negative 2 times 1 is still negative 2. And then if I add 3, that's going to give me the number 1. Okay, so I set x equal to 0 and I found y was equal to 1. Okay, so 0, 1. For the y-intercept, x will always be 0. It's just up to us to find what y is. To find the x-intercept, we're going to do pretty much the same thing, but in reverse. Now we're going to set y equal to 0 and solve for x, the opposite of what we just did. Okay, so our equation is y equals to negative 2 times x minus 1 quantity squared plus 3. But again, I want to set y equal to 0, so let me do that here. And now let me solve for x. At this point, you might be tempted to start expanding this. You might be tempted to say x minus 1, let me go ahead and square that, and then let me distribute the negative 2, and then let me add the 3, and that'll give me a quadratic in standard form. And then I can either extract the square. If I'm lucky, I can factor, or if not, I can use the quadratic formula. All of that is correct. You can definitely do that, and it's going to be way longer, way more complicated that way. Here, this is already a completed square. You can extract the square from this one without modifying it at all. Just isolate x. Let's go ahead and subtract 3 from both sides. That makes that go away. So this will give me a negative 3 equals negative 2 times x minus 1 squared. I'm going to divide both sides by a negative 2. Again, I'm trying to isolate x, so let's get rid of this part right here. Negative 2. That goes away. Negative over a negative is a positive, so that's a positive 3/2 is equal to x minus 1 squared. Now let me take the square root of both sides so that I can get rid of that square. Now remember, when you take the square root, there's 2 different square roots. There's a positive and a negative. So that's plus or minus the square root of 3/2. So here, that's going to be x minus 1 is equal to plus or minus the square root of 3 over the square root of 2. All right, square root of 3 over 2, the square root of 3 over the square root of 2. Let me rationalize that slightly. Let me clean that up so that the denominator looks a little nicer. So let me multiply both top and bottom by the square root of 2. So now that's square root of 3 times square root of 2. That's the square root of 6. Okay. On the bottom, square root of 2 times square root of 2, that's square root of 4. Oh, but I know the square root of 4. That's just the number 2. That's why I did that, to get rid of the square root here. I don't want to deal with 2 square roots. 1 is enough. So I get x minus 1 is equal to that number there. And finally, let me go ahead and add 1 to both sides. Add 1 to both sides. That makes that go away. And that'll leave me the x all by itself is equal to positive 1 plus or minus the square root of 6 over 2. And there we go. Here are our x values. It turns out we're going to have 2 x-intercepts, right? I have 2 answers here. So my x-intercepts, nope, my y value has to be 0, but my x values are these numbers. My x values are going to be 1 plus the square root of 6 over 2 comma 0, and separately 1 minus the square root of 6 over 2 comma 0. Just like that. So now, these points combined with a parabolic shape, combined with the shape of a parabola, will give me the graph of this function. So let's go ahead and do that. Let's go ahead and form a graph. Let's begin by plotting these points. Let's put these on the graph. All right, so let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay. 1 comma 3. That's 1 to the right, up by 3. 0, 1. That's going to be right here. That's our y-intercept. Okay. Now these, you might say, okay, well, I don't know what to do with those. I know how I can find 1 comma 3, write 1 up 3. How do I find this? I don't know what that number is. 1 plus root 6 over 2. What number is that? So here, the square root of 6 is what's tripping us up. I know what the number 1 is. And I know what dividing something by 2 is, right? If this was just regular 6 over 2, I could do that. 6 over 2 is 3. I know how to divide by 2. I know how to add the number 1. It's that square root of 6 that's throwing us off. I don't know the square root of 6. Fortunately, I do know a bunch of other square roots. In fact, I know the square roots of every perfect square. Here, the square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 4 is equal to, of 16 is equal to 4. Square root of 25 is equal to 5. And so forth. I can keep on going There's a bunch of square roots that we know, right? Square root of 1, square root of 2, square root of 3. Oh, sorry, the square of 1, the square of 2, the square of 3, the square of 4, the square of 5. And you say, yeah, but that doesn't help me because I don't want the square root of 1, the square root of 4, the square root of 9, or the square root of 16. I want the square root of 6. Okay, well, I don't know exactly what the square root of 6 is, but I do know that it's got to fall somewhere between these two numbers. 6 falls between 4 and 9, which means the square root of 6 will fall between the square root of 4 and the square root of 9. Or in other words, it falls between 2 and 3. I know that 6 falls between 4 and 9. Well, sure it does. Okay, well then that means the square root of 6 would fall somewhere between the square root of 4 and the square root of 9. But I know what those numbers are, 2 and 3. So here, I don't know what the square root of 6 is, but I know it's somewhere between 2 and 3. So let's say it's about 2.5. Let's say it's about 2.5. Is that absolutely correct? No, it's not. But it's close enough. Because what we're doing here is we're graphing. And these graphs require us to find a location somewhere along the x-axis or the y-axis to place our intercepts. And even if we don't have exactly that value, if we know its approximate location, that's good enough to find a graph. So here, I don't know the square root of 6, but it's about 2.5. It's about 2.5. So here that means the square root of 6 is about 2.5. Okay, so now let's look at this. Square root of 6, well, that's about 2.5. Okay, so now divide that by 2. 2.5, if I cut that in half, that's 1.25, 1.25. And now if I take 1.25 and I add 1, that's 2.25. Okay, well, there we go, 2.25. So on the graph, that's going to be 2.25, comma 0. That's 1, 2.25, comma 0. It's going to go forward 1, 2, and a little bit more. No one's going to take out a ruler to make sure that's perfectly on the nose, right? This is an estimate anyway. So here, this is 2.25. Just put it somewhere between 2 and 3. That's good enough right there. We do the same thing for this number. Again, the square root of 6, that's about 2.5. And if I divide that by 2, that's about 1.25. So 1 minus 1.25 is a negative 0.25. Okay, so negative 0.25, comma 0. Negative 0.25 is just a little tiny bit to the left of 0. And there we go. Right? 1 plus square root of 6 over 2. That's like saying 1, that's about the same as 1 plus 2.5 over 2. And we know how to do those. If you take 2.5 divided by 2, that's 1.25. Oh, so 1.25 plus 1, that's 2.25. So coming up here, 1 plus the square root of 6 divided by 2 is about 2.25. Okay, so that's about 2.25, comma 0. 2.25, comma 0. And that's it. Now we're going to connect these dots. We have all 4 of these plotted. And now we're going to connect these dots and keep in mind the shape that this is supposed to be in. This is supposed to be a parabola. Since there's a negative coefficient in front, it's going to be a parabola that faces down. And because that's the vertex, that's going to be the highest point of a parabola that faces down. So when you connect the dots, make sure that you don't end up with some other kind of shape. Make sure you end up with a parabola. Here's your vertex. Here's your x-intercepts. Here's your y-intercept. And that's your graph. So go ahead and give this a try. Take the following equation that is in vertex form and go ahead and graph. You're going to graph by finding the vertex, the y-intercept, the x-intercepts, and then plotting those and creating the graph. So go ahead and give this a try. Let's have you try g of x is equal to 4 times x plus 2 quantity squared minus 4. Okay, so go ahead and give this a try. Find the vertex, the y-intercept, and any x-intercepts you might have. Go ahead and plot those on a graph and then connect to form a graph. Whenever you have finished that, whenever you have a satisfactory graph, go ahead and unpause the video and we'll go through it together. Okay, so let's take a look. We have to find a vertex. So let's start with that. When things are in the vertex form, these numbers tell us where our vertex will be. Whatever number makes this part 0, that's our x value. Okay, so here negative 2 plus 2 would be 0, so x is negative 2. Whatever number that is, that's the y value of your vertex. Okay, so that's going to be our vertex. We're going to need to find a y-intercept. And again, that's found by setting x equal to 0. So let's go and do that down here somewhere. Let's set x equals to 0. So that's going to be y equals 4 times 0 plus 2 squared minus 4. Okay, parentheses go first. 0 plus 2 is going to be 2. Then exponents. 2 squared is 4. So 4 times 4. Multiply that, it's going to be 16. And then subtract your 4 to give you 12. So if x is equal to 0, y ends up being 12. So 0, 12. We're going to find an x-intercept the same way. Or possibly x-intercepts. There's often more than one. And we're going to do that by setting y equal to 0. So it's going to be 0 equals 4 times x plus 2 quantity squared minus 4. And now we're going to solve for x. Let's add 4 to both sides. That goes away. And that'll give us 4 equals 4 times x plus 2 squared. We can now divide both sides by 4. Makes that go away. That leaves us just the number 1, which is equal to x plus 2 quantity squared. And now let's take the square root of both sides. To get rid of that square, we use the square root. Now don't forget, whenever you take a square root, there's going to be two values, two square roots, a positive and a negative. So here we're going to get rid of that square to leave us just x plus 2. And now over here, we're going to have plus or minus the square root of 1. Or more simply, just plus or minus 1. And finally, to get that x by itself, we're going to subtract 2 from both sides, and that'll isolate our x. Our x is now by itself, and that's now negative 2 plus or minus 1. Notice those can be simplified. If I have x is equal to negative 2 plus or minus 1, that's the same as saying x is equal to negative 2 plus 1, and separately, x is equal to negative 2 minus 1. That's what plus or minus means, right? Negative 2 plus 1 or minus 1. But each of those are just regular whole numbers, or I guess integers. Negative 2 plus 1, that's negative 1. And negative 2 minus 1 is negative 3. So here we won't have to estimate anything. These are actually nice numbers. We have when y is equal to 0, x is either equal to minus 1 or minus 3. Minus 1 comma 0 and minus 3 comma 0. And that's it. That's all the points we're going to need. So now we can go ahead and graph our parabola. Let's see here. We're going to start off with our vertex, negative 2 comma negative 4. That means we're going to go to the left by 2 and then down by 4. 1, 2, 3, 4. Just like that. That's going to be our vertex. Note that the vertex is going to come from the transformation of a parent function. What I mean by that is, remember in chapter 2, when we had the quadratic parent function, that crossed through the origin. Okay, so now if we were taking this and modifying it by performing the translations, that +2 would move things to the left 2 steps. Then the -4 would move things down 1, 2, 3, 4. Oh, okay, well that's that point. That's what the vertex is. The vertex is what did your transformations do to the point that started at 0, 0. Oh, in this case, it brought it to the left by 2 and then down by 4. Oh, so that's my vertex. So keep in mind, this is not disconnected or different from what we've done before. In fact, it's exactly the same. These transformations change the parabolic parent function, the quadratic parent function, by shifting it 2 to the left and down by 4. So of course that point's going to end up there. We have a y-intercept 0, 12. So that's going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be up there. And then we have two x-intercepts, one at -1, 0, so 1 to the left from the origin, and then -3, 0, which is 3 to the left from the origin. And that's it. So now keep in mind, this is a quadratic polynomial. This is a quadratic function, which means that the graph is going to be a parabola. That's the vertex, which means it's going to be either the highest or the lowest point. And since this is a positive number, that means everything's going to open up, which means that is going to be the lowest point. So let's go ahead and connect our dots and form a parabola. Something like that, yeah? This is freehand, so. No one's being graded for their art skills. And even though this was not part of the question was to simply graph by finding these points. Just to point out that we did mention something about an axis of symmetry. An axis of symmetry is a vertical line which essentially cuts the parabola in half, cuts it into two symmetric pieces. We noted that in our definition, we said that x is equal to h is the axis of symmetry, where h is the first coordinate, is the x coordinate of our vertex. Visually, what that means is, okay, if here's your vertex, pass a vertical line through it, and that will cut your parabola in half. Right? Which here, you can fairly clearly see that even though my drawing is maybe not great, it does appear that this side is a reflection of this side over this straight line. To give the equation of this, it's always going to be x is equal to, well, what is the x value here? Well, let's see, that's my vertex. The x value of my vertex is -2. Okay, so x equals -2. And this is the axis of symmetry. And that makes us happy. Now, in the examples we've seen so far in this section, we've been graphing a quadratic that's in the vertex form. Keep in mind, that's not the only way a quadratic equation can look. In fact, many times, it's going to be in the standard form. So let's take a look at an example of that. How do we graph something that's in the standard form? Let's start off with a function f of x is equal to 2x squared minus 4x minus 3. Okay. The reason the previous problems were not particularly cumbersome, were not particularly long, was because this was in the vertex form, which just told us, hey, here's the vertex, and then by just plugging in a 0 in an appropriate spot, either here or here, we could find our intercepts. Over here, it's not quite as nice because it's not in the vertex form. Okay, well, then let's put it in the vertex form. Whenever you have something that is written in the standard form, one option is start by writing it in the vertex form. All right, so to write this in the vertex form, we're going to complete the square. All right, so here we go. When you're completing the square, the first two terms, you're going to bunch them together and put them in parentheses. We're going to take our constant, just move it off to the side over here, -3. Okay. Here, f of x, in fact, let me just leave that as f of x here. Don't bring anything over this way or anything like that. We want everything on this side. that's the way the vertex form looks. The vertex form looks like your function's name on one side, basically y on one side, everything else on the other. Okay. To complete the square, take your first two terms, bunch them together, take that constant, push it off to the side. Your next step, take your lead coefficient and factor it out, which means write it on the outside, and then all the numbers inside are going to get divided by that number. Well, 2 divided by 2 is 1, so that gives me 1x squared. Minus 4 divided by 2 is minus 2, so that'll give me minus 2x. That doesn't affect anything on the outside, so that's still just a minus 3. Notice that's still 2x squared minus 4x minus 3. So we really haven't changed our function. We made it look different, but it still says the same thing. All right, now to complete the square, we're going to take this number, we're going to cut it in half, and then square it. Okay, so half of negative 2 is negative 1. And when you square negative 1, you get a positive 1. Okay, but now to balance out the fact that we just added a random plus 1, now we need to subtract 1. Take these three terms, bunch them together. That last one, it would cancel with this one if we left them together, but we're going to kick that to the outside. So we're going to write this as 2 times x squared minus 2x plus 1. Now, as this comes to the outside, remember, anything in the parentheses is being multiplied by 2. So as you bring it to the outside, don't forget to multiply it by 2. 2 times negative 1, that's a negative 2 minus 3. Notice this still says the same thing as we had before. This is 2x squared. Okay. This is minus 4x. Okay. This is plus 2. Well, that's not a plus 2. Oh, yeah, but that plus 2 minus 5, oh, that would give you minus 3. Okay, so even though this looks different from what we had before, it still says the same thing. And finally, factor this. What two numbers multiply to give you 1 and add up to give you negative 2? Well, that's going to be minus 1 and minus 1. So we can write this as x minus 1 times x minus 1, or more simply, x minus 1 squared. Here, these are just numbers. Negative 2 minus 3 is negative 5. And there we go. That's in the vertex form. So now we can graph that exactly like what we did just a few minutes ago with the other ones. All right? So here, let's find the vertex, which we can find by inspecting this. Here, what makes that 0? Well, that's the number 1. Okay, so 1 is the x-coordinate. And here, whatever number that is, that's the y-coordinate. So we're going to use 1 comma negative 5. To find the y-intercept, we're going to plug in x is equal to 0. Now notice, we have several different versions of the same function. All of these mean exactly the same thing. So yeah, we can plug in x is equal to 0 right there, or we could choose one of the other ones. If we choose this top one, it's going to be pretty simple though, because if I choose this top one, what's anything times 0? Well, it's going to be 0. And same thing here, that's going to be 0. So that's going to be 0 plus 0 minus 3. Well, that's just going to give you that last number. These are going to go away. They're going to be 0. So that's just going to give me if x is equal to 0, this all goes away, and y is equal to minus 3. So the y-intercept is actually a little bit simpler if you use the standard form. Now, if you want, you can use the vertex form, plug in a 0 right there, and it's really only going to take you an extra few seconds to simplify. But this one, you don't have to simplify. If you set x equal to 0, that makes this 0, that makes this 0, and you're only left with the minus 3 to be y. Okay. And finally, to find your x-intercept, here you can set y equal to 0. Okay, now here, again, we have two choices. You can set y equal to 0 here, or you can set y equal to 0 here. In this case, it's sort of a matter of preference. Some people prefer to set this one equal to 0, and then say, oh, I can use the quadratic formula here. Other people prefer to set this one equal to 0, and then say, oh, now let me extract the square here. It will give you exactly the same answer. It makes 0 difference, so just choose whichever one you like. Since we have been extracting the square so far, let me go ahead and do that one more time. I'm going to set y equal to 0 and extract the square. If you prefer, you can use y equal to 0 here and then use the quadratic formula. All right, so if I set y equal to 0, that's going to give me 0 equals 2 times x minus 1 squared minus 5. All right, let's add 5 over to both sides. All right, that way you can get rid of that minus 5. That's going to be 5 equals 2 times x minus 1 squared. The 5 has now been added over. Let me divide both sides by 2. And that's going to give me 5 halves is equal to x minus 1 squared. Now, to get rid of that square, I need to take the square root on both sides. And remember, when I take a square root, that's going to get rid of that square, but it's going to give me two values, plus or minus. All right? The square root of 5 over the square root of 2. Right? When I take the square root of this side, that'll just give me x minus 1. Here, I have two square roots, one on top and one on bottom. So let me go ahead and clean that up a little bit. If I multiply the bottom by root 2, the top, root 5 times root 2, that's going to be root 10. But the bottom, root 2 times root 2 is root 4. And I know the square root of 4, that's just 2. So here I can at least get rid of one of those square roots. And if I'm going to get rid of one of the square roots, I would rather it be the one on the bottom, because we're going to have to graph this. So I have a much easier time dividing by 2 than dividing by something that's got a square root in it. And finally, let me go ahead and add 1 to the other side here. And so that's going to give us, the x is now by itself. There's now a plus 1 over here. So it's going to be plus 1. And then plus or minus the square root of 10 over 2. And there we go. That's going to give us our two x values that make y equal to 0. Or in other words, it's going to give us our two x-intercepts. So that's going to be 1 plus the square root of 10 over 2, comma 0. And then separately, 1 minus the square root of 10 over 2, comma 0. Okay. Keep in mind, we don't know the square root of 10, but we can get a pretty good guess. After all, I know that 10 is between 9 and 16. And you say, yeah, it's also between 0 and 50. Why did I choose 9 and 16? Because those are the closest numbers to 10 that are both perfect squares. Meaning, I know how to take the square root of both of them. There are other numbers that I know how to take the square root of, but they're not as close to the number 10. I could do 25, but that's a lot bigger than 16. I could do the number 4, but that's a lot smaller than the number 9. Here I want the closest numbers to 10 that I know how to take the square root of. So 10 is between 9 and 16. So the square root of 10 has to be between the square root of 9 and the square root of 16. Or in other words, it has to be somewhere between 3 and 4. Okay, so the square root of 10 is between 3 and 4, so let's say it's about 3.5. Is that right? No, not exactly, but it's close enough. So the square root of 10 is about 3.5, say 3.5. Okay, so now we can use that to find our points here. 3.5, more or less. If I take 3.5 and divide it by 2, if I take the square root of 10 divided by 2, that's about the same as saying 3.5 divided by 2. And that's going to give us 1.75. Okay, so now 1 plus 1.75. Oh, I can do that. 1 minus 1.75. Yeah, I can do both of those. So we can go ahead and graph now. Let's plot the points we have. 0, negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. So 1, negative 5. That's going to be 1 to the right and 5 down. We have a y-intercept of 0, -3. So from the origin, we're going to go down 3 steps. So there's a point. There's a point. And now this, now remember, square root of 10 over 2, that's about 1.75. Not exactly, but close enough for a graph. 1.75 plus 1, well, that's 2.75. So that's going to go 1, 2, almost all the way to 3. On the other hand, 1 minus 1.75, that's a negative 0.75. So not even all the way to -1. And there we go. This is going to be a parabola because we have a quadratic. That lead coefficient is positive. Whether you look at it here or here, notice it's the same number either way. That's positive, which means it's a parabola that faces up. So the vertex will be the lowest point, and then from here it's going to be a parabola opening upwards. And there's our graph. Note you do have an axis of symmetry here. It is the vertical line x is equal to. Note that your vertex is 1, -5. So at the vertex, x is equal to 1. And there we go. This is our graph. Now, if your equation starts off in standard form, changing it to the vertex form will allow you to graph the way we've been graphing. However, we have seen in previous sections that completing the square can sometimes lead to some messy numbers. Here, these numbers work out relatively nicely, right? -1, -5, +2. The only number that was slightly unfortunate was these numbers here. But depending on what our equation looks like at the beginning, these numbers can work out quite a bit worse. You can work out in a situation where they're not anywhere near this nice even. So let's take a look at one other alternative, which is reminiscent to the quadratic formula. Here, to find the vertex, we put the equation in the vertex form. Okay, well, we remember that the vertex form always follows the same pattern. There's 4 steps that you take. And if you take those 4 steps, you end up with the equation in the vertex form. But if it's the equation in the vertex form, those numbers, whatever they might be, have to give me my vertex. So what if I do that more generally? What if I try to find the vertex without knowing what the numbers are ahead of time? We did that when we were trying to find solutions to a quadratic equation, and we found the quadratic formula. Here, we're going to do something similar. We're going to say, okay, let's write this in the vertex form. Write in vertex form. I'm going to take a function, f of x, and I'm not going to specify what the numbers are. I'm just going to say, here's the most arbitrary quadratic function that we can make. The one where we don't know any of the numbers. Just ax squared plus bx plus c. The most generic possible quadratic formula, quadratic equation you can write. Quadratic function you can write. So now let's complete the square. We saw how to do that. You're going to take the first 2 terms and bunch them together. Okay, so that's going to be ax squared plus bx. And then you're going to take that extra number and just leave it on the outside. Okay. The next thing you're going to do is you're going to take that lead coefficient, that 2, bring it out. You take that a and bring it out. When you do that, you're going to divide each of these things on the inside by a. And here, when we took out the 2, we divided these numbers by 2. When we take out the a, when we factor out a, we're going to divide each of these numbers by a. Okay, well, a divided by a is 1, so I'm not even going to bother writing that. B divided by a is, well, it's b over a. Like that. Doesn't affect anything on the outside. That number out here stays the same, regardless of what we do to this stuff over here. Okay, so now we're going to take this number, we're going to cut it in half, and then we're going to square it so that we can write it here. Okay, so let's do that. Here's your number. You're going to take b over a. You're going to cut it in half. Okay, so let's do that. Let's take half of it. 1/2 of b over a. Okay, well, that's 1 times b is b, and 2 times a is 2a. So that's half of b over a. Oh, but it's not enough to just take half of it. You also have to square it. Okay, so let's square that. And if you square that, that's going to give you b squared over 2 squared, which is 4, a squared, like that. So take this number, cut it in half and square it. It'll give you that. So go ahead and put that right here. Plus b squared over 4a squared. But remember, whatever you write in there, you're going to immediately subtract it away to keep things balanced. So minus b squared over 4a squared. So now, take just the first 3 and keep them together. Take the last number that you had over here and kick it out. Don't forget to multiply it by that number on the outside as you're kicking it out. So here we can write this as a times x squared plus b over ax plus b squared over 4a squared. And as this comes to the outside, we're multiplying it times a. So that's going to be negative b squared over 4a squared times a. Okay, so a times b squared over 4a squared. Plus that c that was already out there. Okay? If you multiply this times that, that gives you that. Those all stayed right where they were, and c stayed c right where it was. Here, that a can divide out one of those a's, so we can even write that one a little bit more simply. That a divides one of those a's, and we can write that as b squared over 4a. So that's going to be a times x squared plus b over ax, plus, that's a plus sign, plus b squared over 4a squared, minus b squared over 4a plus c. Okay? And now we can factor this. Now that looks very complicated. You say, how am I going to factor that? Well, remember how these factor. The whole point of completing the square is to make this a perfect square. What we do is we say, what two numbers multiply to give you this and add up to give you this? Well, we're expecting these to be the same numbers. So here, it's going to be a number plus itself will give us that number. Or in other words, this number here will be half of that number. Okay, when we factor, this number here will be half of that number. Oh, we already know half of that middle number. We already know half of that middle number. That was this up here. We took half of that middle number. That gave us b over 2a. So this part right here will factor as x plus b over 2a squared. And then you have your a in front. And then here you have this other stuff, minus b squared over 4a plus c. And that's the vertex form. Notice that's number times x plus a number squared plus another number out here. All right? A times x minus h squared minus k. All right? Okay, so that's the vertex form. So what this says is that the vertex is given by, okay, remember the vertex, the x coordinate is whatever makes this 0. Okay, so if that's positive b over 2a, if I plugged in a negative b over 2a right here, that would make that 0. Negative b over 2a plus b over 2a, that would just give me 0. So here I want the first coordinate to be negative b over 2a. I want the second coordinate to be this stuff. I want it to be negative b squared over 4a plus c. And there we go. There's a formula for the vertex. Notice it doesn't look like the quadratic formula, but in a way it kind of does. It uses the values of a, b, and c to tell you what your vertex is. We can write this part a little more simply because notice this is the x coordinate of your function. But remember how functions work. If you know the x coordinate, you can just plug that into your function and that'll tell you the y coordinate. So here, if you don't want to remember this second part, you can just say, okay, if I know the first part, I can take that, plug it into the function, and that'll give me the second part as well. So here, even though this is the vertex, a lot of people don't even bother remembering the second one. They'll write it this way. Negative b over 2a, that's going to be the x coordinate. And then the y coordinate will be negative b over 2a plugged into the function. In other words, f of negative b over 2a. So as a partial example, when I say a partial example, I mean I'm not going to do the full graphing. I'm just going to show you how to use this to find a vertex. Let's say we were going to graph something. Let's say we were going to graph a quadratic. F of x is equal to, let's say 3x squared plus, I don't know, let's go with 12x plus 1. Yeah, that should be fine. So let's say we're going to graph that. Okay, well, one thing we could do is we could write this in the vertex form by completing the square and then proceed to find the vertex, the x-intercepts, and the y-intercepts. Basically do what we did in the last problem. But instead, what we can do is we can say, well, all right, if I can just find the vertex, that's already one of my points. And to find the x-intercept and the y-intercept, to find the x-intercept, I just plug 0 in here. And to find the y-intercept, I just plug 0 in here. Yeah, it's going to be a bit of work, but so is writing things in the vertex form. It's not really any shorter to do it this way, but it's also not really any longer. So it's a kind of a matter of preference. Which one do you want to use? All right, so here, let's find the vertex. All right, let's find the vertex. The vertex is going to be given by negative b over 2a, comma, f of negative b over 2a. All right, well here my b is 12 and my a is 3. So negative b over 2a is equal to negative 12 over 2 times 3. All right, negative b over 2 times a. Well, that's going to be negative 12 over 6, which is negative 2. Okay, so the x value is negative 2. You say, what about the y value? Well, take that negative 2 and plug it into your function. After all, that's how functions work. If you know what the x value is, plug it in, that'll tell you the y value. So now, let's go ahead and find f of negative b over 2a. That's going to be f of, well, we just found negative b over 2a is the number negative 2. So let's do that. If we plug negative 2 in here, that's going to be 3 times negative 2 squared plus 12 times negative 2 plus 1. Negative 2 squared is 4. And then 4 times 3 is going to be 12. 12 times negative 2, that's negative 24. And then plus 1. And now 12 minus 24, that's negative 12. But then if I add 1 to negative 12, that'll give me negative 11. So there's my vertex. That was my x value, and here's my y value. Negative 2, comma, negative 11. Okay. Now, we know that's not enough to create a graph. That would be a good start, though, find the vertex. Well, what else do we need? Well, we need a y-intercept. Okay, well, let's do that. Let's now find the y-intercept. The y-intercept you find by setting x equal to 0. Okay, well, let's do that. I have an equation right here. F of x equals 3x squared plus 12x plus 1. F of x equals 3x squared plus 12x plus 1. And what I want to do is I want to set x equal to 0. Okay, so let's find f of 0. That's going to be 3 times 0 squared plus 12 times 0 plus 1. Oh, well, that one's nice. 0 plus 0 plus 1. That's just 1. Okay, so we're done with that one. The y-intercept, x is equal to 0, and y is equal to 1. So we have our vertex, and we have our y-intercept. The last thing we would need would be the x-intercept. Okay, so let's find our x-intercept. We do that by setting y equal to 0. Okay, well, that's your y, so set that equal to 0. That's going to be 0 equals 3x squared plus 12x plus 1. And now to solve that, well, we could complete the square to solve that quadratic. But if we were going to complete the square, we would have just done that already, right? If we were going to complete the square, we might as well have done that to find the vertex, and then we wouldn't have needed this formula anyway. So here, we were probably trying to avoid completing the square in the first place. So the other way of solving a quadratic is to either factor or use the quadratic formula. Since we're looking at formulas anyway, we just saw the vertex formula. Let's go ahead and use the quadratic formula for this one. Okay, so let's go ahead and solve by the quadratic formula. That's going to be negative b plus or minus the square root of b squared minus 4ac. All of that divided by double the value of a. Now let's plug in those numbers. Anywhere we see a b, we're plugging in the number 12. A is the number 3, and C is the number 1. All right, that's negative 12 plus or minus the square root of, let's see, 12 squared is 144 minus 3 times 4 is 12. And then over here, 2 times 3 is 6. 144 minus 12 is 132. Over 6. Now, 132 is not a number that I can take the square root of, unfortunately, but I can factor that, since that can be written as 4 times 33. 132 can be written as 12 times 11. It can be written as 2 times 76. But the reason I've chosen this pair of numbers is because, yes, they do multiply to give me 132, but also one of these numbers is a perfect square. So I'll be able to take its square root. I'll be able to simplify. Okay, so that's going to be negative 12 plus or minus. I don't know the square root of 33, but I knew the square root of 4. That's just 2. So that's a 2. Here, the square root of 33 stays like that, all over 6. And now we can actually reduce and simplify those. We can write that as negative 12 over 6 separately, plus or minus 2 root 33 over 6. Like that. All right, divide that by 6, separately divide that by 6, and then both of these reduce. Negative 12 over 6, that's negative 2, plus or minus 2 over 6 is the same as 1 over 3. So you can write that as square root of 33 over 3. And there we go. We find our x-intercepts. There's 2 of them. If y is equal to 0, x is either equal to negative 2 plus root 33 over 3, or it's going to equal to negative 2 minus root 33 over 3, comma 0. And there we go. Using these 2 numbers, negative 2 plus that or negative 2 minus that. And then, of course, the y value is 0, because that's how you find an x-intercept. And there we go. Without completing the square, we found our vertex. We found our y-intercept. This relies on some formulas. So it's not significantly longer than what we've seen over here, completing the square versus using the quadratic formula and the vertex formula here and here. It's not really that much of a difference. It's just a matter of preference. Some people like formulas better. Some people like the completing the square better. Let me go ahead and write these all down. If you are going to complete the square, well, then you complete the square, get it in the vertex form, and you're good. You can go from there. If you are going to use formulas, remember the 2 formulas that we need are the quadratic formula, which says the solutions to ax squared plus bx plus c equals to 0 are x equals to negative b plus or minus square root of b squared minus 4ac all of this divided by 2a, and the vertex formula, which says the vertex of the graph of f of x equals ax squared plus bx plus c is negative b over 2a, comma f of negative b over 2a. So if you are going to use formulas, make sure you use them correctly. And here they are. All right, so that is it for the section. If anybody has any questions, comments, problems, please make a note of them and reach out to me. You know my contact information, and if not, you can ask next time we meet. I hope everyone has a nice day, and I'll see you next time.